Today again we will discuss on partial differential equation. That is the lecture 3. I request at first you must go in differentiation. Okay, what is D? Already we have discussed. What is partial differential equation? Already we have discussed. What is limit? Already we have discussed. You must go in the previous lecture, then you will understand what we are doing here. Okay, so sometimes you will get such type of function. This is a function. In this function you can see that there are more than one variable. Okay, this is a one variable, this is a second variable. In your high school intermediate you have seen such type of function, x ki power 4 plus x plus 2, and after then you have to differentiate. Okay, you have differentiate del df upon dx. You know that you can differentiate only with respect to x if this variable is available here. Okay, then you can differentiate. If you cannot differentiate with respect to y because there is no y. Okay, so in this condition you will differentiate like this. Okay, this is the how to differentiate. What is the meaning of d, what is the meaning of f, what is the meaning of x, already we have discussed. You must go in the previous lecture. And this is the single variable function, and this is the multiple variable function. Okay, you can see that here more than one variable. Maybe you can get more than one variable, z, maybe x, y, z, t. Okay, so there are more than one variable. Okay, what is the meaning of this? What is the meaning of this? What is the meaning of this? So you have seen also in the coordinate you use such type of point. Okay, suppose this is 1 1, then you represent this by the help of this method. Okay, what is the meaning of this? If you are finding volume, then you use such type of function. Okay, then you will use this is the z. And what is the meaning of t? T means time. If you have studied the relativity, okay, so we use such type of function. Okay, so with respect to time, what is the actual position of any object? So we use this type of function. Okay, so here we are not discussing this and this. Okay, here we are discussing if you have any such type of function, then how to differentiate. Okay, this is a problem. Let we have written here z is equal to, this is the function, is equal to f of xy, that is the variable, and z is the function. So after then, if there is a variable, and suppose in any question that is the variable inside, this is also function, and with respect to t. Okay, means xt means you have such type of function, t square plus 1, maybe anything. Suppose yt is equal to sin t. Okay, anything. So this is also function. It's behave also function. We have input two variable inside this function, but these variable are also function of t. So you will write in this manner. Okay, so in this condition, how to differentiate such type of function? So in this condition, suppose you have to differentiate this z with respect to t, then you will write dz upon dt. So at first you will check that how many variables are here. There are total number of 2 variables. Okay, and these 2 variables are also behaving like function. So there is a t and there is a t in this x, in this y. Okay, such like this, anything they can give you. Then in this condition, at first you will differentiate this z with respect to x because there is only one variable. Okay, you differentiate, then after then you will differentiate this x with respect to t because there is a t. After then you will differentiate this function z with respect to y because the second variable is this. Now in this variable it is also working like function, and this is yt. So then this you will differentiate this y with respect to t because t is inside this function. Okay, so suppose you have another function and there are total number of 3 variables, and these variables are also behaving like function. Okay, so after then you will represent this function u like this. U is equal to f of means function, xt, yt, zt. In this condition, how will you differentiate? So you can see that in u there are total number of 3 variables, x, y and z. So at first you will differentiate x, u. At first you will differentiate u with respect to x because x is here. Then you will differentiate u with respect to y because y is here. Then you will differentiate u with respect to z because z is here. Okay, you differentiate x Okay, you differentiate u with respect to x, you differentiate u with respect to y, you differentiate u with respect to z. Now this variable are behaving like function. Okay, so in this x there is a t, means just like this. Okay, so you will differentiate this x with respect to t. So now del x upon del t. Then in this y there is also variable del y upon del t. Then del z upon del t. Okay, so this is the manner to find if you want to differentiate such type of function, then you will use this manner. Okay, now suppose in the examination they have given you this question. The question is z is equal to x square plus y square. They can give you any question. They have given you this question, and they have also given you here x is equal to a cos t and y is equal to b sin t. Y is equal to b sin t. You can see that this is the function, and in this function there are total number of 2 variables. Okay, now you have to differentiate this function. So dz upon dt, you have to differentiate this function. So there are total number of 2 variables. At first, why we are using this symbol? Whenever you have such type of function, in this function if there are more than one variable, then you will use this d. This d and this d both are same, behave same, but expression is different. Why? Because whenever you have such type of function, there is only one single variable, then you will use this d. Whenever you have such type of function, there are more than one variable, then you will use this d. Working principle is same. This is also differentiate, this is also differentiate, but it's indicate that it is differentiating such type of function where you have more than one variable. It is differentiating such type of function where you have only single variable. Okay, so that is the meaning of this d and this d. Now at first you will differentiate this z with respect to x because there is a x variable. Okay, then you will differentiate this z with respect to y. Okay, now this z also, this x, it is a cos t. Inside this x there is a variable t, inside this y there is a variable t. So you will differentiate with respect to t to this variable, this function. It is working just like function. Okay, so then this is you can see also dx upon dt, dy upon dt. Why we are just using this symbol and this symbol? Why we are using this symbol? Because this z, it is taking more than one variable. Why we are using this d? Because this function, it is taking single variable. Okay, this is why we are using this d, because this z, it has more than one variable. Z is the function. Okay, why we are using such type of d? Because this y, that is the function, and it has single variable, and that is t. Okay, now so now you will differentiate this function with respect to x at first. Okay, now this is the, suppose this is equation number a. At first we have to differentiate this z with respect to del z upon del x. So this will be treated as constant. If you are differentiating with respect to x, then it will be 0. In this condition you will get 2x. Now second time you have this del z upon del y. Okay, now you have to differentiate this z with respect to y. In this condition you will get 2y. This will be 0. Now after then you have to differentiate this x with respect to t. Okay, so then you will get a cos t is equal to sin t, but it is negative. Okay, now you have to differentiate y. Okay, you have to differentiate y with respect to t. So you can see that b cos sin t is equal to cos t. Okay, so now you have to put everything here. Okay, now dz upon dt is equal to del z upon del x is equal to 2x. Okay, then dx upon dt is equal to minus a sin t, then plus, then del z upon del y is equal to 2y, then this dy upon dt is equal to b cos t. Okay, now you can see that this is minus 2ax sin t, and this is plus 2by cos t. That is the answer. Okay, I think that you got. Okay, so that is the answer. Okay, now I will solve one another question, then it will clear your concept. I am just erasing it. Now this time they have asked you this question: if u is equal to function of, okay, there are total number of 3 variables r, s and t, okay, and he has given you r is equal to x upon y, s is equal to y upon z, t is equal to z upon x. They can give you any question. Your concept must be clear. Now he is asking, prove that x del u upon del x plus y into del u upon del y plus z into del u upon del z is equal to 0. You have to prove this question. Very simple. Okay, so it means that we have to differentiate u with respect to x. If we will differentiate u with respect to x, then we will check that what will happen. So del u upon del x, okay, del u upon del x. So if you are differentiating u with respect to x, so total number of variable are 3. So at first you will differentiate u with respect to r, because there are r variable. Okay, so in this condition your value it will be, so del u upon del r. Why? Because one variable, then plus del u upon del s, then del u upon del t. Okay, so why we have used this this symbol? Because in this function there are more than one variable, so we are using this symbol. Okay, so now in this r you can see that there are two variables. In this r, that is also a function, but in this function this is not a single valued function, this is also multiple valued function. Okay, you can write also r, that is x or y. Okay, this is a function and this is x upon y. You can write like this. That is the short form. Okay, s is also multiple valued function, this is also multiple valued function. So whenever you have multiple valued function, then you will differentiate this r also with respect to x, okay, this s also with respect to y, and this t also with respect to x. We have to differentiate with respect to x, so we will use x. Okay, because we have to differentiate with respect to x, so every time we are using x. Okay, but we differentiate r with respect to x. So now you can see that in x there is no any other value. Okay, so if you will write dx upon dx, that is actually 1, so I will not write here. Actually here also you will write dx upon dx and dx upon dx, dx upon dx, but it is 1. I am not writing. So now I will solve it. Du upon dr is equal to, you will differentiate u with respect to r, then you will differentiate u with respect to x, then you will differentiate u with respect to t. Okay, I am writing short form of this function. U r means I am writing this, its meaning del u upon del r. Now del r upon del x means this r you have to differentiate with respect to x. So the 1 upon y, that is constant, and dx upon dx is equal to 1. So total answer is equal to 1 upon y plus del u upon del s. I am writing this. Okay, its meaning is this, ds upon dx, ds upon dx. Now you can see that there is no x. Okay, in s there is no x, so 0. Okay, plus ut. Okay, t we have to differentiate with respect to x, then its meaning is actually this, then you will get z x minus 2. Okay, then you are getting minus z x minus 2. Okay, if you will differentiate t with respect to x, then you will get this result. Okay, now similarly del u upon, why we are doing this one? Because we have to prove. Okay, del u upon del y, again you have to differentiate u with respect to y. It means that in u there are total number of 3 variables. So at first we will differentiate with respect to r, then we will differentiate with respect to s, then we will differentiate with respect to t. Okay, now in r there are total number of 2 variables, so del r upon del y, del s upon del y, because we have to differentiate with respect to y, so we are using this. and del t upon y. Okay, you can also, if you have any misunderstanding, then you can also think that both are same. Okay, this. Okay, now we are using the short form UR. It's both meaning are same. Del u upon del r, del u. I am writing the short form. Okay, so del r upon del y. R you have to differentiate with respect to y. Then you are getting minus x y की power minus 2. Okay, then us del s upon del y. Okay, then you are getting 1 upon z. Okay, then plus del u upon del t. Del u upon del t, this is ut. Del t upon del y, there is no y, this is 0. Okay, now again you have to differentiate with respect to z, this u. Okay, so again in u there are total number of 3 variables. Okay, del u upon del r, then del u upon del s, then del u upon del t. Okay, now you have to differentiate r with respect to z. Okay, del r upon del z, then you have to differentiate s with respect to z. Okay, del s upon del z. Okay, and del t upon rt, del t upon del z. Okay, so now I am writing again short form del r ur. Okay, del u upon del r is equal to ur, del r upon del z. R this r we have to differentiate with respect to z, but there is no z, so this is 0. Okay, plus this is short form del s upon del z. Del s upon del z is equal to, this is z below, then it will be minus y z की power minus 2, then plus this is short form, both are same, del t upon del z, del t upon del z, so you are getting 1 upon x. Okay, so this is the equation number first, this is the equation number second, this is the equation number third. Now the first equation you have to multiply by x, second equation you have to multiply by y, and third equation you have to multiply by z, because he has asked us to prove this. Okay, now we will multiply by x. Okay, then you are getting, okay, multiply by x this. Okay, then and then after then add, multiply x into 1 plus y into 2 plus z into 3. Okay, you have to do. Now multiply by x upon y, u r. Okay, this 0. Okay, ignore it. Then minus z. Okay, this is actually z upon x square. This is actually z upon x square. It means that if you multiply by x, then you will get z upon x. Z upon x u t. Then you have to multiply. Then after that you have to add plus. Okay, now you will multiply by y. Again you can see that this is u r. Okay, but if you multiply by y, then again y will cut, because this is 1 upon y square, y cancel, then you are getting x upon y, so minus x upon y, so this is minus x upon y. Again you multiply by y, okay, multiply by y, then you are getting y upon z del, this is us. Okay, now this is 0, ignore it. Again this is 0, ignore it. You have to multiply by z, then you are getting this, again cancel, then you are getting minus y upon z us. Again you have to multiply by z. Okay, z upon x ut. Okay, now you can see this is ur, this is ur, this is x upon y, this is x upon y, this is minus, this is plus, both are cancelled, this and this cancel. Okay, so now you can see this is ut and this is ut, z upon x, z upon x. Okay, this minus, this is plus, cancel. Okay, now you can see this is us, this is us, this is y upon z, y upon plus and minus, both cancel. So you can see that when you add, multiply by this, multiply by x, multiply by y, multiply by z, and after then add, then you are getting 0. It means that x into del u upon del x plus y into del u upon del y plus z into del u upon del z is equal to 0. That is the answer. Okay, so they will ask, they can give you any question. You have to use this. This is chain rule. Okay, its name is actually chain rule. Okay, You have to use this method, then your answer it will be grouped. Okay, so its name is chain rule. You must note it. That is the chain rule. Okay, I think that you understand. If you have any query, then you can ask me. Thank you so much.